Okay, so today I'm gonna be solving this problem. Maximize happiness of the selected children. So my idea is so basically that was given that happiness array, and then from this happiness array I need to select. It represents the children that have like every child has his level of happiness, and I need to select k is equal, like I need to select two children, in this case like k children, and every time I select a child, other children decrease their happiness. So let's say I selected 3, and it means that 1 becomes 0 happy and 2 becomes like 1 happy. And then next time I need to select whatever, like next children, I select the middle one, and the aggregate, like his happiness becomes like 1, and like the leftmost child happiness is 0, and it cannot go below 0. So the maximum happiness I can get from children from this array is like 3 plus 1, and this is gonna be like 4. So I should return 4. So how to solve the constraints are pretty, I would say, the happiness array can be quite large. So my idea is here is to basically take the happiest child, and then like, because like everybody gonna decrease their happiness, everybody who's left gonna decrease the happiness by 1. There is again, like in order to maximize the total sum, I need to pick up the most happy child adjusted for the decrease in happiness, and by taking the most kind of the highest the happiest child, I just can. It's interesting that this I can even like solve it without sorting. So I need just to take not really. So I need to take top k element from a happiness array. If I can take the top k, yeah. Yeah, so I will just do the following. I'll sort the happiness array, happiness.sort, and then I'll go for, so I'll have this while k is greater than 0, and then I'm gonna have the pointer I is equal len happiness minus 1, and then I'll do while k is greater than 0, I'll do k, so we're gonna have the result equals 0. So I'm gonna and decrement is equals 0 initially. So I'm gonna have result plus equal happiness I minus decrement, and then if happiness minus decrement is greater than 0, else it's gonna be 0. Let me do this, and let's do this. Let's do this brackets, and then I'll do decrement increase, and then okay, let's do this brackets, all like this spaces. So decrement increase, I gonna decrease, and k gonna decrease, and then I'm gonna return result. So that's basically the solution. Happiness Happiness again. Yeah, this is a solution. And I'm right now thinking about, okay, can I improve that even further? So if I can have efficiently select n top n, so the time complexity here gonna be n log n. So I can think about merge sort when I let me think about if I can come up with something interesting. So here, if I do, so we have this array happiness 1 to 3. So I have happiness equals 1, 2, 3. Oh, like even let's say 2, 3, 4, 5. 2, 3, 4, 5. Let's say k is equal, say 5, or like let's say k is equal 2. So I select the middle one, and then middle value, and then I need to to move the middle value to the front, and then have like 2 pointers moving. So I'll move like there's gonna be 2, 4, 5, and then I need to find the place for the for the 3 to insert. So I'm trying to do the merge sort here, and like the variant for the selecting top n element. And then they say that it should be of n time complexity. So if I select the 3, so I selected somehow like randomly the 3, and then I should basically reallocate the array so that so I split like the array into 2 parts, and like should put the 3 in the middle, and then should put 2 on one part and 4 and 5 on another part. And then I'll say, okay, 3 is it has index 1, so all elements to the right, there are like 2 elements that are bigger than 3, and 1 element to the left that is smaller than 3, or like smaller or equal. So even if I have like all of n for the, so there, it's a question. Okay, let me search. What is efficient way of selecting top k elements? Yeah, in the worst case scenario, it's gonna be O of n squared. Oh, yeah, I can do that. Or I can maintain the, I can do that with a heap. I can do, what? So I need to go through all elements. That is gonna be n log k. Yeah, n log k. So if I do heap here, I need to go and have a min heap and insert the value, and then like if the min heap becomes larger than size, I need to remove the element from a min heap. So it's gonna be something like what heap, so let's say heap equals a heap like this, and then I can do actually heapify, heap pq heapify happiness, and then I can so this one's gonna be O of n. And then I have, let's say, for what this was heapify for h in happiness. I wanna reverse it. Okay, reverse heap order Python. Okay, so as I said, okay. Max heap, okay. For happiness minus h. Okay, let's say we have this happiness, and then heap high happiness, and then wall case I wanna do heap pq, heap q, heap pop, and then say happiness, say car h gonna be heap pq heap pop, and then from the happiness it's gonna be -1 multiplied by this, and then happiness minus decrement. Actually, yeah, we can do this, and then k minus 1. Okay, something like this. Rest is equal to 0. Decrement is equal to 0 also. much worse. Even though like the time complexity now becomes time becomes of k log n. Okay. Uh, yeah, it's no, not really, because like this heap is really huge, so it's gonna be n log n. So I need to, let's say we have heapify. Yeah, that's true. Okay, heapify. I don't wanna heapify. I wanna just heap equals just this one, and then for h in happiness, I wanna heap pq heap push minus h, and then if len if len heap is greater than k, I want to do heap pq heap pop, and then heap, and then in the end I wanna heap pop heap from heap, and then if car h. Okay, I can just go through the array what's left and do this. For, let's say, heap in, for like let's say happiness in heap. In heap I wanna do sum probably, and then I need to subtract the decrement, but it might be actually 0. So if it's equal 0, what's gonna happen? Like if it's if I run out of happiness for kid before actually recording the result. Okay. Yeah, it's a little bit difficult. So again, like I'll do this heap sort. So sort, gonna be heap dot sort, and then for h in heap I'm gonna go res plus equal, say for I in range len heap, I'm gonna go result equals result plus heap I multiply by -1 minus decrement, and then decrement plus plus, and then and this one is if so it should be somehow so I'll do this for I in range, say enumerate for I, and then H in enumerate heap. I'm gonna go heap I minus I, and then here multiply by -1, and then for val in this array, I wanna do if val greater than 0, else 0, and then val, and then sum. So return sum. Can we do this? Heap, okay. Okay, it's also gonna be enumerate something like this, -1. Oh no, actually something like this. No. So like this one should be, if it's has a, so it should be minimal in the front. So I'll push the heap, and that, let's say, print heap here, print format heap. 2, 3, okay. And then if I do enumerate heap, let's say -1. Three, 2, okay, that's good. Say sort, something like this. How much minutes I already doing that? Okay, 24 minutes. So we have heap, and then 3, 2, and then output is 0. Okay, so not -0. I forgot that. For no reason, I was thinking that I should reverse the heap and like have maximum in the front. So let's do this. No. Interesting. Okay, let's do this. use this case. Let's run it. Let's print heap and heap -1, and then let's print it. So it's gonna be 42 and then 12 and then 1. And then I should do 42 and then plus 11. Huh. 42 plus 11 gonna be 53. Okay, heap h what is this? h minus I. Okay, that's interesting. That should have worked. Why? So if I do this heap I, because like here it's like reversed, and then I'm directly accessing. Okay, then yeah, that shouldn't work. Okay, let's try to assess. Yeah, it's a little bit not that better. Yeah, all those efforts and not really better. Yeah, okay, I'm gonna wrap up. Probably it's a good idea to do this quick sort plus greedy max heap priority queue plus PD. Okay, yep. Okay, that was the solution. Hope you like it. I was using some extra time. Heapify. So this one is OFN, and then okay, K. So OFN, and here it's gonna be K. So this one solution gonna be K. No, it's gonna be hip hop, so it's gonna be K log n, and in my case it should be n like K log n plus n. It's gonna be ofn because heapify is ofn. And then in my solution, the time complexity gonna be Leetcode. So my solution gonna be, so I'm pushing to the heap, so it's gonna be time complexity gonna be of so the heap gonna be maximum k, so log k, and then here gonna be n log k, and then and then plus, and then here I'm gonna have this sort, so it's gonna be k log k, and then plus k. So like overall it's gonna be n log k, and a Leetcode solution is k log n, and the Leetcode solution is actually better. Because like n is greater than k. So if I do first, so do this. If I do happiness hippify, hip pick you, hippify, and then happiness, and then I'll do so I need to select the maximum. So I'll do this happiness initial. I'm gonna have this happiness equals minus h for h in happiness, and then for, so it's gonna be array equals list. So for, let's say while k is greater than 0, I'll do heap pq, heap pq, heap pop, and then here happiness. That's gonna be a dot append, and then -1 multiplied by this value. So, and then next I'm gonna go and then sort it, a sort, and then I'm gonna have this one, and then reversed, something like this. Oh wait, so k minus equal 1. Index out of range. Okay, let's submit. This should be better, but again, let's say I can do first k elements, happiness, let's say from just do this a equals happiness, and then it's gonna be 0 up to k plus 1, or just k, and then here I'm just gonna do so here it's gonna be 0k, okay, and then sort, and I need to reverse, and then here I'm gonna be -1 multiply. Happiness. Okay, let's do print format a, and then a. Let's use this use case. So the A gonna be minus 28 and minus 2. Wonder why. Ah, okay, so because it's a heap, and then I should like take a, okay, yeah, that makes sense. So it's gonna be empty while k is greater than 0, a dot append heap pq heap pop, then happiness, and then here I can multiply by -1, or like I can skip that one and then sort, and then k minus equal 1, and then heap pop. Do I need to sort actually? No, I don't. Okay, let's run it. Still not that great. What's people doing here? Happy. Okay, just sorting. Okay. I'm gonna wrap up. That's it.